Hello, my name is Colin, and I'm here to do a second talk on querying your iModel. This one is entitled Super Query Spatialistic Aspect Alidocious. And we're going to cover some more advanced topics and some tips and tricks that you can use when you're in design review to understand what you've actually selected and figuring out how to query it inside of the iModel console. If you have not seen the previous talk, check it out on YouTube and check out the documentation that's also published on GitHub. The links are right here and they should be in the notes for the talk. Now let's hop right in. So we went over this in the previous talk, but I'm going to just briefly bring it up again. What is an iModel? It's a SQLite file. It's got a fixed table structure that's designed for performance and scalability, and we put an extensible metadata layer on top of it so you can have much more friendly and semantically rich queries. This metadata layer is called BIS, our Base Infrastructure Schema, and the language we use to do queries is EC-SQL, which is basically just SQL, except for we're talking classes and properties instead of tables and columns. And you can do joins just like you normally would in SQL, but we also have some specially defined joins that we call relationships. They map to foreign key or linked table relationships that you would have in a normal database. You can access this iModel with our open source libraries, and in this talk, we'll be using some of the services that come with iTwin platform, and we'll be using the free account and the sample iModels that you get when you sign up for a developer account. So if you're not already signed up, go sign up at developer.bentley.com. And once you've signed up, head over to the registration dashboard where you can add sample iModels. In this talk, we'll be mostly using the Stadium sample, although a couple of the queries will be from the Metro Station sample, which is another pretty cool example. I will extensively be using the iModel console and iTwin Design Review, but I want to remind you that the iModel Reporter and the iModel Schema Explorer that were brought up in the previous talk are quite helpful, and you might end up using them if you dig a little bit deeper into this. So let's hop right in and talk about Design Review and some tips and tricks when using Design Review. So first and foremost, we got to get to Design Review. Well, how do you get there? Start over here at your registration dashboard, pick the model that you want to pick, click Connect to Web Portal, and then click the iModel, click View, and you'll get planted here in Design Review. So the first thing that we're going to do is we're just going to select an element. We're going to use the selection tool, and we're going to zoom in a little bit more so it's easier to see what we're doing, and we're going to click on an element. Now, when you click on an element, the property pane will pop up, and it'll show you stuff about that particular element. So if I click on another element over here, I'll see different stuff. If I click on something completely different, you could see, click on a roadway. So you're getting this information from the iModel live. Now, how is this information getting to you? Well, let me click on a piece of glass here, and I'm going to hop over into the Dev Tools. So I'm going to click here on Get Page Content, and I'm going to scroll down to the bottom where I can look at the request payload. And if I expand this, I can see that I've selected a physical object and I can see its ID. Now, this ID is a 64-bit integer. I discussed it in the previous talk. It's a super fast way to search for an element within an iModel. It's unique within that iModel, but it's important to note that it is not universal, as in it's only within this iModel and only within the lifetime of this element in the iModel. If you want some more universal identifier, having a coded element, something like that, using our code system or using Federation Good, those are some of the other things that you can use to uniquely identify this element. So I'm going to search for this element in iModel console. I'm interested to see what I just saw in Design Review in the console, right? Because we've got these glass materials, all this stuff. So I'm going to say select star from generic physical object where EC instance ID equals blank. Okay, so I've selected it. Now let's scroll over and look at the properties. So as I scroll over here, okay, I see some stuff, but I don't see glass. Why is that? Okay, I've selected the element, but I am not seeing the property. So let's hop back over here into design review. And we want to find these properties. So what we're going to do is we're going to go back and we're going to take a look at the dev tools again. And now we're going to look at the response. Oh, okay. Sorry, we have to take a look at, and we'll just pull it up again. Click content descriptor, look at the response, preview. Okay, now it's loaded. That's not even our software. Okay, so gonna expand here and we're gonna look at the fields. Okay, so I'm gonna move somewhere down because I'm thinking, oh, I picked the right one right off the bat. So I see glass element aspect, that looks promising. I'm gonna look at nested fields and I can see glass material, glass type, and if I hop back over, sure enough, glass material, glass type. So I found it, but where is this stuff coming from? Okay, so if I look at this content class info, you can see that this is DGN custom item types, SS steel structure glass element. So want to actually search for this guy. So I'm just going to copy this out because it's a long thing to type. Copy here. We're going to go back into iModel console and I'm going to say select star from blank where element .id, and this is one of those good old relationships here we're talking about. It's a foreign key relationship, and I'm going to say where it equals that ID that I selected before. Now as I scroll over, okay, now I'm seeing the information that I expect to see from that aspect. It's not connected to the thing yet, but I'm seeing it. Okay, so next, I want to see what the raw unformatted values are and what the formatted values are that I'm seeing here. So I'm going to hop back over into the dev tools. Well, I'm going to have to, once again, select my element again so I can get a fresh, and we'll get page content. And I can see that this one is going for the property pane. That's what I'm interested in. As you can see, there's two of them for the same selection. And so we've got the same descriptor that we've seen before, but now if we expand into the actual content set, we can see display values and values. Display values are the formatted values, and the values array are just the unformatted ones. So if we take a look here, you can see element model, and it lists the display label for the model. If you come down here and look at the unformatted value, it actually lists the foreign key property value for that model. So this is the ID of the physical model that contains this element. Now if we go down to the glass aspect that we are looking for, you can see it's a nested structure, and we've got display values and regular values here, and this kind of matches what we were seeing over there. One thing I want to note is you can see here we've got a thickness which is stored in the database as 0.01, and when we display it, we show it with its units. Everything in iModel is stored in SI units, so if we wanted to see this in feet, this would be converted into feet and show the feet display label, whereas this would stay unchanged. Now, I want to show one more thing about presentation rules, and then we'll hop into actually querying. So presentation rules is super cool. It drives a lot of the stuff that you see in Designer View, and it drives this tree. So this tree shows the model hierarchy, and we do a bunch of stuff to pretty it up, and we can get that for you now. I'm just going to flip between trees here to force it to reload and expand, expand, expand. Okay. So now if we click on one of these get page node calls, we'll be able to see what we requested. So I'm going to scroll here. I'm going to look at my request, payload. I'm going to expand rule setter rule ID, and then I'm going to expand the rules. So these are the rules we're actually using to define the tree. So you can see here root node rules. So this is a rule that defines what the root of the tree will look like. So it's going to be a BizCore subject. Its parent is going to be null. So there will only be one subject with no parent. It's kind of a parent hierarchy. You can check it out on, there's a link in the docs to what the subject hierarchy looks like. But that's our root node. If you see here, we've got other subject child nodes, and you can write rather complicated rules that probe into the data and help you build up a custom tree. Now, of course, this is the default tree that you can get from our open source repo, and you can actually go find this in our open source repository by either clicking the link in the docs or searching for this ID in our repo, and you'll pull it up. If you want to find all the presentation rule sets in our repo, you can search for this JSON schema and you'll pull it up. So I just want to bring this up. We aren't going to delve too much into presentation, into the tree views and these hierarchies or presentation rules in general. Just want to bring up, it's a super cool, super powerful piece of technology that it's put at your fingertips. Okay, so the next thing that we want to do is actually dig into querying for aspects so we can get some more information about this element that we have selected here. So one obvious thing that we can do is we can query for all aspects. So there's two types of aspects, multi-aspect and a unique aspect. There's links to documentation with some more details about the difference between the two. But I'm just going to query for all multi-aspects. So it's not going to show me a whole lot of information here because I'm querying for the base aspect class, so there's no properties, but you can see there's a lot of external source aspects. That makes sense. The external source aspect identifies where an element came from when it was synchronized and brought into the iModel via a connector. So we can join this aspect to element using the element.id navigation property on every aspect. And so this is pretty cool. I can see the element, but I'm still not seeing any element specific or aspect specific properties because it is, I scrolled too far. That's right, it will reopen. And it has. So I'm not going to run that query again. I'm going to move right on to the next one. So it's not showing any of the actual details about that element, but you can see that there's a connection. Next, when you're trying to figure out what's in an iModel, it's very helpful to do kind of a generic overall query that tells you what classes are in the iModel, and in this case, I want to find the classes that are in the iModel and what aspects are connected to those classes. So I've got this query here where we're selecting an element class ID. We're getting a grouped array of distinct aspect classes, and we're grouping by class ID. So as we do this, you can see that once again, just like we saw before, there's a lot of external source aspects. That's most of what most classes have. But then when you look at physical object, there are a huge number of aspect classes. Why is this? Well, generic physical object doesn't have many properties of its own, and it's used to represent many different things. So to add those properties on, we use element aspects. Now this is a great and handy way to augment an existing element, an existing class with additional properties. The downside is it's a little bit harder to query for them. So what we're going to do is we're going to first query for excuse me, query for the elements, the element aspect for a particular element, and then we're going to join in the aspect, and finally we're gonna query them all together and select all the properties so we can see them all. Now I think I picked a different element ID than I was using earlier, but that's fine. You can see there's two element aspects here. That's why we've got two rows, and it's this glass element aspect and the external source aspect. So I'm going to now use a query that actually specifies the individual classes more directly here. So you can see we've got this glass element aspect, and we've got external source aspect, and we're joining them both in. Okay, now if we look at this, as we get over here, see now we've got glass structural element, and now we have the properties that we were seeing there. Now there was one pair I didn't join in, but for everything I did join in, you can see we're seeing properties just like we saw in the property pane. Obviously not formatted, but they're there. Okay, so the next thing we're going to do is spatial queries. Spatial queries let you select things based on a bounding box. So inside of an iModel, there is a spatial index, and that spatial index is designed for super fast bounding box lookups. So I'm just going to select star from biz.spatial index. And you can see we have a column which is the ID of the element and the ID of the spatial index, and then we have bounding box defined as min and max XYZ point coordinates. So just to show that in fact we have bounding boxes for different elements, here is the element ID I just queried for up above, and you can see it's got a bounding box. So the next thing I'm going to do is actually create a bounding box myself and select a whole bunch of elements. My goal is to identify all these glass panels along the side here. So you know, I clicked on the two endpoints, and I figured out about what the bounding box should be, and I just created it here. So you can see I am finding everything in the spatial every ID in the spatial index that's within the bounding box, and then I am joining there, and I'm also joining in category. That's not really necessary, but it's actually pretty useful. Okay, so you can see here, this is the code value from the category, and you can see why I joined it in. It's telling us information, pretty high level information about what it is that we have selected here. So there's a lot of stuff, a lot of little pieces here, and I actually want to modify this to just be those glass elements. So I'm going to add a join into that element aspect. This is one of the fancy, nice things that you can do with element aspects. It's kind of like you can do a polymorphic query across many different different main element classes that have no real common base class. You're just kind of querying, hey, find me every element that has this aspect applied. Now, I mean, in this case, they're all physical object, but you really can apply an aspect to any element, and you define that when you define the aspect. So it's a great tool for identifying stuff across the hierarchy and adding in some properties. So I'm going to query for this, and you can see we have many fewer results now, just 16, and we've got dome entrance glass, dome glass, and so if we go over back here to design view, you can see that this is dome glass, and if I zoom in a bit here, I've got entrance glass. So, we're zoomed out a little bit too much. So you can see here, we're able to select stuff by bounding box, and there's actually a whole bunch of really powerful functions that you can use that, essentially spatial functions that you can use, and they're linked in the talk notes, but I'm not going to go into them in more detail here. Now, the next and final piece that we're going to dig into is hierarchical queries. So what does this mean? It means a query that is going to recursively select stuff in the iModel. These are super powerful when you want to walk trees or graphs, and iModel.js, and iModel and Biz use hierarchies quite a lot. Like, for example, we looked at the subject hierarchy when we were looking at the model tree. And you have assemblies, which are, an assembly of elements make up something together. And we actually, in designer view, you can control the assembly scope here as well. And so you can use recursive CTE queries to traverse these hierarchies. I'm going to show you two here. They are kind of similar because they both use the parent-child relationship, but parent-child relationship is quite heavily used, but you can use this for anything you like. There's a lot of great examples out there on SQLite's flavor of CTEs, and we have a couple great articles in our learning content, which is linked here. So I'm going to copy this query out. And remember, what this is going to do is query our subject hierarchy. It's going to start with one of the leaf nodes that we saw in designer view right here, and it's going to walk back up the tree. Now, we aren't going to see exactly the same tree because designer view has more rules than this, but it's pretty cool to be able to do this in a single SQL statement. So you see here stadium at one end, and here's the dome cable connection at the other end. And as we walk through, there's some similarities and there's some differences. In here, there's some differences, these three. But if you look at the presentation rules, you can see how they're suppressing and hiding things and pulling up different labels for stuff as they walk the tree. But I'll leave that as an exercise up to you. Now, another thing that can be really helpful when you're looking at iModel is trying to understand how things are connected to each other. And so another CTE that we're going to use here is this one, which actually kind of builds a kind of relationship path between connected elements. So in the first example, I picked one in particular because I already knew about it. But if you want to just see what's out there, you can do a CTE like this. And you can do them for all different types of elements. You can even pop up the class hierarchy using a CTE. It's pretty cool stuff. So I've sorted by the number of connections because I guess the more connections, the more interesting, right? That's logical. And you can see here right at the top is the one we actually picked above, and there's a whole lot more here. And these are all subject hierarchy. These are all subject hierarchy relationships. That's pretty much what's in this model. You could create another thing that you could do if you want to, here I've shown code value, but if you wanted to see just what was in the model, it might be very helpful to just show the class, for example. And you can do this with all kinds of information. It's a standard CTE. It's quite powerful. And yeah, well, that's pretty much all I have to show today. I want to encourage you to go on to the GitHub IO page or my GitHub page and check out the docs for this talk and the docs for the previous talk. They're up here. I'll update them if anyone finds any mistakes. And thank you very much. And we can take your questions.